Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hafiz bin Muhammad Khushairi. I'm under the supervision of Tun Muhammad Firdaus bin Aziz, and today I will be presenting my final year project, Rice Porosity and Bulk Density Effect on Certiphilus oryzae, rice with oviposition distribution. Introduction. Rice or Rhiza sativa L is a common staple food grain that is high in fiber, energy, and other biomolecules. Rice is also the world's most extensively consumed. Staphylococcus aureus is one of the most common insect pests that degrade agricultural food commodities quantitatively and qualitatively during post-harvest storage, as aureus can also cause serious damage on the sensory and physical aspect of the grain. This has led to grain losses which are estimated to be around 10% worldwide and roughly 20 to 30% in the tropical zone. Problem statement. Many articles wrote about the oviposition preferences of rice reveal compared to the oviposition distribution of rice reveal. There's also limited information regarding the locality of which part or level inside of the storage container of the grain that was preferred by the rice reveal to oviposit. Significance of study is to observe the oviposition distribution of rice reveal on different types of rice, and also to help in formulating new management tactics to overcome the infestation problem caused by rice reveal. Objective. First, to determine the bulk density, rice porosity of brown and Japonica rice. Next, to determine the adult and oviposition distribution of S. oryzae on brown and Japonica rice. To analyze the effects of rice death on the vertical distribution of adult and oviposition distribution of S. oryzae. And lastly, to determine the association of bulk density and rice porosity toward adult and oviposition distribution of S. oryzae. Methodology. Some of the method is the measurement of rice, weight, length, width, and the thickness. Next, the calculation of bulk density, true density, and rice porosity. As for the oviposition, the container for brown and Japonica rice was set up as the picture above. And after 14 days, the number of adult S. oryzae in each level was collected and separated from the infested rice. The infested rice was left for additional 27 days, and the new number of new adult emergent of S. oryzae in each level will be collected. Statistical analysis. The data will be analyzed using variance mean ratio (VMR), t-test, Pearson correlation test, one-way analysis of variance (ANOVA), and also test of independence. Result and discussion. As we can see here, figure 2, measurement of brown rice and Japonica rice. Brown rice is a type of long grain and Japonica rice is a type of medium grain. So as we can see from the figure above, the length of brown rice is longer compared to Japonica rice because long grain usually have longer length compared to the medium grain, and Japonica rice in the other hand have wider width compared to the brown rice due to the nature of medium grain that is wider compared to the long grain. And both of them, the brown rice and Japonica rice, have equally thickness of the rice. And for table 1, we can see the bulk density, rice porosity of brown and Japonica rice. As we can see here, bulk density and rice porosity can range from 0.76 gram per milliliter to 0.87 gram per milliliter and 22.68% to 50.15% for brown rice, depending on the varieties. And the bulk density and porosity of the grain might also be influenced by the surrounding factor, and some grain bulk densities increase as moisture content increase, whereas it decrease in other environment. Next, we go to the adult and oviposition distribution of S. oryzae on brown and Japonica rice. So table 2 and table 3 show the statistical analysis, the variance mean ratio analysis on data of adult and new adult emergence. As we can see here, the value VMR more than 1 indicate that the presence of clumps, while smaller value VMR smaller than 1 indicate a more uniform distribution. And based on these two tables, we can see that the VMR of the data of adult SRIZ and the VMR of the data of new adult emergent is more than 1. So it indicates that the distribution of SRIZ is in clump, which correlate with the visual observation of SRIZ during the research. And the distribution pattern of SRIZ might also increase the surrounding temperature, thus affecting the oviposition distribution, as the highest rate of oviposition of SRIZ was obtained at 30 degrees Celsius to 35, but reduced at 20 degrees Celsius or 40 degrees Celsius. And table 4, we can observe here, table 4 is the t-test on data of adult and new adult emergent of SRIZ. As we can see here, the p-value from the t-test of adult and new adult emergent show that the value is more than 0.5. So value higher than 0.5 indicates that brown and japonica rice have the same distribution pattern on adult and new adult emergent of SRIZ, and this might be because the behavior of SRIZ that prefer to be in the clump that directly affecting the oviposition distribution area. Next, we go to the effect of rice depth on the vertical distribution of adult and oviposition distribution of SRIZ. So table 5 shows the Pearson correlation test of adult and new adult emergent of SRIZ. So as we can see from table 5, the value is negative for adult and new adult emergent in brown and japonica rice. And the negative value of Pearson correlation shows that there is a negative relationship between the depth of rice and also the numbers of new adult emergence. And based on the analysis, the deeper the depth of rice, the lower the number of adult and new adult emergent of SRIZ. Next, we can see here figure 3 and figure 4 shows the distribution of adult SRIZ and also new adult emergent of SRIZ in brown and japonica rice. So based on these two figures, we can conclude that SRIZ prefer to be at the top layer compared to the bottom layer. Might be because of the oxygen level at the top is higher than at the bottom level of the container. So SRIZ also might try to prevent hypoxia or low oxygen level. They're able to slow the insect pest population growth by reducing mating, egg laying, progeny development, and lifespan of the species. And next we have table 6 and table 7 that shows the ANOVA test on adult and new adult emergent of SRIZ. For ANOVA test, we only look at the p-value here, and the p-value near 0 indicate that the difference observed is unlikely to be, whereas the p-value near 1 or equal to 1 indicate that there is no difference between the groups. And based on these two tables, we conclude that all the data are valid to be used in analysis and there is no difference between the group. And based on the distribution also, the younger adult may have higher reproductive rate compared to the older adult. Thus, container with higher number of adult of SRIZ might have higher number of new adult emergent. This is because the number of egg decrease at the female age because young female ovaries contain more follicle and mature egg than older female ovaries. Next, we go to the association of bulk density and rice porosity toward adult and oviposition distribution of SRIZ. Table 8 and Table 9 shows the result of the independent test of adult SRIZ. As we can see here, p-value more than 0.05 indicate that there is no association between the bulk density, rice porosity, and the oviposition distribution of SRIZ. And based on this table also, we can conclude that adult SRIZ can still move and successfully lay eggs within the container without being affected by the bulk density and porosity of the rice. This is because an increase in the number of visits resulting in the oviposition. And also, the nutrient content may also affect the oviposition and growth of SRIZ that directly might affect the rate of new adult emergent during this research, as the protein and starch content of rice cultivars had an important impact on the SRIZ performance and digestive physiology. And also, the variation could be caused by the difference in host grain, temperature, and the relative humidity. Conclusion and recommendation. In conclusion, the bulk density and rice porosity of brown rice are 0.754 g per ml and 47.04%, and the bulk density and porosity of Japonica rice are 0.894 g per ml and 33.49%. And the variant mean ratio VMR value of adult and new adult emergence shows that VMR is more than 1, and this indicates that the distribution of adult and oviposition are in clump. And for the Pearson correlation value, we can see the negative value, which indicate that there is a negative relationship between the depth of rice and the number of arizae. And this means that the number of arizae is decreasing when there is increase in the depth of rice. And lastly, the result from the test of independence shows that the p-value are higher than 0.5 for the adult and new adult emergence, and this signifies that bulk density and rice porosity have no effects on the adult and oviposition distribution of S. oryzae. Some of the recommendation for further research is to use young adult of S. oryzae for research, and next, minimize switching and moving the container, and record the temperature and humidity of each layer. This is some of the reference used in this research. That's all for me. Thank you.